Whenever we are presented with object-oriented programming, it is very important that we understand that object-oriented programming is a programming paradigm. The word paradigm gives you a notion that it is an approach, it is a way, it is a structure, it is how organized code. In this structure, we focus a lot on classes and objects. Please, I hope you can hear me. No? No?
Yes, sir. We can hear you. Yes, sir. We can hear you.
So it focuses a lot on objects and classes. But in this, there are paradigms to object-oriented programming, or there are rules that object-oriented programming follows, which are encapsulation, abstraction, inheritance, and polymorphism. To achieve these principles, the first question we must ask ourselves is, what is a class? A class, what is it? A class is a blueprint or a template for creating objects. A class is a blueprint or a template for creating objects. Idiot, more class for creating objects. So, whenever we say the word object in programming, we are not talking about the physical objects we can touch every single day. That's not what we are talking about. We're not talking about the things I can hold and feel and do all of those things. That is not what I'm talking about. An object is a word used for a group of like-minded items. If I say student, it is a group word. Before you can be called a student, there are certain things you must have. And not just you, every single person who calls himself a student must have these sets of characteristics before they are determined to be a student. If I say course, every course has something about it that makes it a course that would make you come and sit in the class for it to be taught. To have a course code, a name, description, what do you even call that thing called? An outline. So whenever we say object, we are talking about the group word for the thing. But I have lied a bit. You see, the group word of the thing, I can't use it. For example, if I take student, or even simpler for me, if I take course, every course will have a course, a code, a name, a description, a department, and a prerequisite. But let's not add that. So before you can be a course, you must have a course code. So let's say 001. You must have a name, let's say English. You must have a description to teaching people how to speak. So you must belong to a department. Maybe you belong to the general studies department. So the general studies department. So you having the general studies department, you having this, you having that, you having a description, let's say, um, uh, let's say, help people speak. You having this, you having that makes you a course. So, in defining an object, in defining a singular object, a singular entity from course in programming, I have created an object. You see, the first one in which I was telling you was the word entity. And in English, normally we mistaken entity with entity set. And I know I'm getting a bit confusing here, but let me make everything simple. If I have a course code and a course name and a course description and a course department, I have just described what makes something a course. I've described it. So if I come to you and tell you, oh, create a course for me, your job will just be to give it a code, a name, a description, and department, and you are done. You have created a course. In programming, this description here is what we call as a class. Now, when I provide the description with values, for example, when I say the course code is 001, when I say the course name is, let's say, English, when I say over here is to teach, and over here I say it belongs to the general studies department. I have created an object from the class course. The class, its job is to define the attributes that make up the thing. Is to define the makeup. Now, once it is defined, when you provide values to what has been defined, then you have created an object. So if we look at the definition of the word class and we look at the definition of the word object, we can see that a class is a blueprint or template for creating objects. It defines the fields and attributes of the class, the name, all of those things. But it doesn't only do that. It also defines the behaviors of the object. A course can be taken by students. A course has a number of credits, so there are a number of hours you should be taking off. What behaviors make you up? You see, when it comes to object-oriented programming, my focus in that programming is to look at an individual, be it a course, a building, whatever it should be, and look at what makes that thing it. And once I do that, then I also look at what behaviors does that thing do. So that is my approach to coding. Now, when I create that, then I can say an object is an instance of a class. So when I create rules for you, and I then give those rules values, I have created one rule out of the rules I created. Hence, I've created an instance of the rule. So I can't use the class because they are the rule. But I can use an object because it is me implementing the rule. I'm implementing the rules. I'm doing the rules. For example, I'm starting a new project in intelligence. I'm going to call this project um, lesson one. And I'm going to create this project. Now, after this project is created, I am going to define what some of the things there are. So I want to Control Shift A here. Control Shift A. Let this keyboard should help me increase the font. Okay, they don't work. So let me see. I want to increase the font. Or you can see. Can you see? Then S. System diagnosis. Well, I asked, can you see? And he said nothing. So I'm assuming you guys can see. So that's okay. So in here, let's begin. I'm going to right click on the main menu. I'm going to go to new, and then I'm going to go to new Java class. I'm going to click on it. And I'm going to create a new class called car. So I'll press enter there, and I'll realize that a car class has been created for me. Let us note the following, that the car class that I have created is starting with a capital C. Classes always, always, always start with a capital C. So created a car class. In my car class, I'm going to say that for you to be a car, you must first have a brand. So here I have a brand. And you must first also have a speed in which you go to. So my speed is going to be an int. Also, I'm going to say that void show details into brackets. And then in here, my void will not have any um, parameters, but to just say system.out.print ln, and then in here, I would say the car brand is plus brand from the top, and also, comma, the speed is plus speed, which is in like kilometers per hour. Wonderful. So in here, I've created a class called car. Now, when I come over here, I need to tell or create an instance of the class called car. Over here, I've spelled out what makes something a car. I said if you are to be a car, you must have a brand, you must have a speed, and at any time you can show details, and then that is what you can do. It is very important for us to note that when we say attributes, technically we are telling you the variable. So here we have or the variables. And then over here, we have the actions or the methods. So we use these two things to define a class, your attributes and your behaviors or your actions in which you perform. So I've defined my class called car. Now I must use my class called car. I must implement my class called car. In order for me to implement my class called car, I need to create it in the main function because everything runs there. Now, there is something we need to look at critically, and there is an idea in which I want to plug into you this evening. So, in here, we're going to create a lesson dot draw IO. And then in here, I'm going to create my lesson. Now, whenever we are in class and I tell you to do int num1 is equal to, let's say, 35. So I tell you to do something like this. For now, we all understand that in your computer's memory block, you have created, so this is the memory block. You have created a space in the memory block. The space should be big enough for an integer. The space has a name called number. And in this space, you have put the 34. We have an understanding of it. Now, this int in which you have here, how do you know it is an integer? It's an integer because the computer has predefined that this should be an integer. As much as the integer defines the size of this spot here, if it should be this big or that big or this big, it also defines what should be kept in there. That is why when you say this should be an int and you go and put in an a over there, the computer tells you, hey, that's an error because you said this should have an integer. So the computer knows the properties that govern the space being an integer. Wonderfully and quite obviously, I am going to create car. And I'm going to call it, let's say car. Let me say car, and then the name of my car will be car one. So if I create car one, looking at it, looking at here and here, this int goes with car, and this car one goes with number one. That means that technically what I am doing is I am telling the computer to create a space for me, make that space big enough for car, and in here, it should give it an address called. That is what I have done here. So this coding which I've written here is the same as this one, num1 car one. But there is a problem. And here is the problem. The computer knows int already. So it knows how to format things into int already. The computer doesn't know car, has no information about car. You created the car. You built the car class. So there is something I have to do here. I have to tell the computer that this thing I'm creating over here is new. So go and pick all its rules, all its properties from the constructor. Car into brackets. So what you've done here is you've told the computer that capital C car into bracket here is the constructor, and that is the keyword given to it. And the job of the constructor is to give the space you have provided all the properties that govern the class. For example, in our earlier lessons, we will do scanner con is equal to new scanner into bracket system dot in. Now, whenever we do this, we are telling the computer that we require the scanner class and we need a space for it and we are calling it con. But in this space, let it have the properties of the scanner class specifically with system.in. So this scanner, this part of it is the constructor. The job of the constructor is to construct the object, is to give the computer the properties it requires. You see, you don't have to do that with the int because the int, the properties are already known. They are built in. They are predefined. So if you're a very smart person, you'd realize that the whole objects and classes is just a way for you to create your own data types. So here I'm just telling the computer, create a data type for me called car, and then store it over here called car1. And then give it all the properties I have defined for it and keep it there. So that if someone goes to enter something which is not supposed to be there, you can flag that thing as an error. You can flag that thing as a mistake. Are there any questions? Are there any questions?
No questions, sir. No.
So back to my IntelliJ. If I say car1 is equal to new car, I have just told the computer everything in which I just said. Now, the person who is very observant, the person who is very knowledgeable, would ask the question, where is this constructor coming from? Because in the car.java, I don't have any constructor over here. I don't have anything starting with a capital letter with brackets over here. Over here, the class name, there are no curly brackets at the end over here. There is nothing over here like this. There is nothing there. So there is no curly brackets over there. So where is this curly brackets thing here coming from? What location does it come from? You see, the idea is that every single class you create by default has a constructor in it. So even if you don't do the constructor, there is already a constructor built in this. One second, I'm coming.
Babe, babe.
So in here, technically, there is already a public car, the capital C, curly brackets, and that. A constructor is always going to start with a capital letter. Always. It's always built with a capital letter. So by default, every single class you create has this in it already. So if I create it or I don't create it or I build it or I don't build it, it is already there already. So that's where it comes from. Now, the idea is that I should be able to create my own constructor, and we will get there. But before we get there, let's see if what we did is correct. Over here, if I come and type car, and I bring a dot over here, you can see I have brand here, speed here. If I click on the brand, I can say the brand is a Toyota. And then over here, if I do car one and I bring dot and I go to speed, I can say the speed of the car is, let's say, 200. So if I come after this and I say car one dot show me the details of car one, and then I now run my code, I would see that at the bottom here, it will tell me that car one is a Toyota, and then the brand is that. So you can see my car brand is this, and then the speed is that. So it's showing me the correct figure. But there is a big problem with this. And this is the first point of our lesson. This is where our lesson begins. This should never be like that. You see, these attributes here are the innermost thoughts of the class called car. It is where I save the brand and the speed. And this image I have here called the main method, which is also a class, is utilizing it. It should never be so. The innermost thoughts of a class should belong to the class alone. The same way, if you like me, if you don't like me, if you like the way I teach, if you don't like the way I teach, whatever that you think of me is kept in your mind alone. And on the day in which you want to release it, being on the evaluation form or being it on something in which you want to vocalize, you would vocalize it and then say it. But until that day, I don't know what you think of me. It's in your head. So I shouldn't be able to access the innermost thoughts of a class if I am not that class, or if that class has not told me directly that, okay, you can have access to something. So in here, when I'm in here and I go all the way here and I type car one dot, I shouldn't be able to see speed and then brand, or even shouldn't be able to show details if I don't want you to see show details. If I don't want you to see it. So if I clear all of this here from there, and I come to my class here, and then I come here and say, this thing here should be private. And this should also be private. Then when I come to the main method, and then I say car one dot, I can't see the brand and the speed again. I can't see it. They are not there because they are not meant for you to see it. It doesn't concern you. It's my thoughts. So they are private to me. Now, once I do this, I have done what is called encapsulation. Encapsulation is the practice of hiding data within a class and allowing access through getter and setter methods. It ensures that the internal state of an object is protected from unintended modifications. My innermost thoughts are meant for me alone. They are mine. They're not meant for everybody. Not everybody should have access to it. Not everybody should be able to utilize it. So they are not meant for everybody. They are meant for just me. So only I can have access to it. Are there any questions?
No questions, sir.
With that in mind, how will I now put in values for brand and speed? So it is here that I will create my own constructor. I will create my own constructor. My constructor will start out as public because it must be seen by other people. It's a constructor, it will be seen by other people. Car, remember it's a capital letter, brackets, and then the body. But in here, I'm going to say string brand, comma, string speed. Then in here, I'm going to do something very important, a word in which I would ask you in the exam. That is this. What is this used for? This is used to refer to the global variable. You can see I said string brand over here. And over here too, I have string brand here. So if I come and write brand over here, which one am I referring to? Am I referring to the one which is global, or am I referring to the one which is internal over here? In my case, this keyword takes the trouble away from me and lets the computer know that this is referring to the one outside here, so that when I bring an equal to sign here and write brand again over here, it knows that the brand I'm talking about here is the one which is internal over here. Over here too, I'm going to say this dot speed is equal to speed. So it knows that the speed in which it's talking about is this one, and then that this keyword refers to the speed that is over here. Of course, the speed here is supposed to be an integer so that both of them can. I made a mistake, so I've corrected it. So now the computer is telling me I have a related problem. When I click on it, it tells me that this place there is a related problem. Why is it? Because this car, which is empty, doesn't exist anymore. I've overridden it by creating my own constructor. And my constructor takes two things. The first thing in which it takes is a name brand of a car. In my case, it is BMW. And then the speed of the car, which is 180. I can create another brand if I want to. So I can say car 2 is equal to new car into bracket. This car is going to be a Toyota. And it is going to have a speed of, let's say, 2000. So now if I tell the computer car 1 dot show me details and car 2 dot show me details, it tells me that, oh, my car 1 is a BMW and my car 2 is a Toyota. You can see it here, telling me that good piece of information. I have managed to hide the most important things of the application away from you. When we meet here next week, we would dive deeper into this. Today, the objective was for us to learn what is a class, what is an object, how will I create the class in code, how will I create an object in code, and how will I do it using encapsulation. When we come here next week, we'll learn encapsulation some more and abstraction some more. As I said, in this course, it's not just about us coding and I'll give you a question and then go and solve and bring it to me, Now we must code understanding the principles. When I give you a question, I will give you the principles I want you to apply, and you must understand the question enough that you can apply the principles. There's a lot of learning in this course. This course is not one to be played around with, because if you play around it, the questions may be set in a way where if you can't implement the principles, you can't solve the question entirely. It is not difficult, but you must learn the principle, and it is very important. When we come here next week, we'll do more encapsulation, and then we will do abstraction. How would we hide information from, how will we hide sensitive information from the user so that the user would only see information that he requires when he requires, and he will not see any other information apart from what he wants to do. And he would see it in a way that makes it simple for him. And we would see how we would do like that to build a simple question using encapsulation and inheritance. So please let your reading be around that area. As always, I will make the video available to you after the class. I hope you will practice, because your age now, you are too grown up for me to apply pressure to you. Those days are over. And the days whereby you use charts to copy an answer and all of those things should be over. You are getting to the point whereby things you do start to matter. So you must start learning the thing. I have to be very clear. So spend time learning. Now, as I know with you guys, there are no questions. Thank you all for never asking questions. So we'll meet again next week.
Thank you, sir.